Hi, we are at UHE, and my name is Sasha, and I'm the developer of the Satin Tape simulation, and we call it Tape Machine. What's interesting about Satin is that we got a tape construction kit, so to say. We don't model a specific device. We say, okay, we have a tape consisting of circuits, an input circuit, a record EQ circuit, and a repro circuit, and then we got the tape and various controls for setting up the sound of the tape, which controls the highs and the low frequency.
Is that like the actual the little controls that you would have on the card on every on the tape machine? Almost like, you know, you used to change with the little screwdriver.
Yeah, these are we call it the service panel, and the service panel controls the interior of the tape that you normally wouldn't touch at all. Using the tape itself is pretty easy. We got a studio mode and a delay mode and a flange mode. And the studio mode is pretty easy. You just have the input gain and you have an output gain, and that's almost half of the story. You got the speed control, which is between 7.5 inches and 30 inches per second, which is mainly how we set up the internal parameters to say, okay, we got a hi-fi tape deck, or we got a full-blown 2-inch studio machine. And I can show you this is a track where we got the drum bus equipped with Satin, and we're still on bypass. So if I unbypass it and just crank up the input gain, you hear that it's saturating a lot, but also it's gluing all the drums. And we haven't touched the interior parameters at all. So we could say, okay, we have different formula for controlling the overall frequency response. You can dial in very different curves, where the NAB is the most beefy because it uses a low frequency bump, and we got the additional head bump effect of the tape. We dial in some, and we can fiddle with the virtual head gap of the repro head, and these are all parameters that are on a real machine, and we modeled them very precisely, because we're using a 150 kilohertz bias signal. The whole tape machine runs at between 370 and 390 kilohertz. It's at least 8 times oversampled. Yeah, and so we can model all the little aspects that a real tape has. And here we are on bypass again, and we just say, okay, this is a machine that's stripped on the whole bus. But I could also say, okay, I want to have a multi-track machine, and that is where our grouping feature appears. And so we have said, okay, I have a group, and I call it drums, yeah, and all the tracks that should come on the group track. I say, okay, this is the kick drum, and I have, for instance, I have the ambience mics and the kick drums, and the grouping feature says, okay, they're all in the group, and they're linked. All the controls are linked, and so we have one big multi-track machine instead of separate instances where I have to copy and paste settings in order to end up with a similar sound. That's the grouping feature. This is available in the studio mode, and it really gets creative when I hook up the other modes. In the tape mode, we have I'm on the drums right now. Yeah, okay. We have a 4 and 2 repro head delay mode. So there I control the distance between the record and repro head. And I got
that's like using a tape machine in old school delay mode, right?
Yeah. So we have a four head multiple delay, multi-tap delay machine with all the stuff that's associated with tape delays. But the cool thing is that all these processes run through our in-depth modeled tape machine. But the real cool thing is the flange thing that we haven't seen on any plugin. At least we couldn't make up one. Normally a flanger would just be an LFO and it would modulate all the time, and it would have a set dry-wet setting where you just have flanging all the time. And here you just say, okay, we have, okay, I'm going to solo it again. So I say, okay, in this passage I'm going to trigger the flanger, and it says, okay, I'm doing it right now. And that goes.
So you just do one cycle?
It's a one cycle.
Jimi Hendrix style?
Yeah, of course. Where you have a song and you want to have, for instance, the solo part, the guitar solo part or whatever, it's just one time flanging, and you couldn't do it with a regular flanger.
It really does sound like tape planning as well.
Yeah. And we could do it on the master, but it's more interesting, of course. So we open up the master and we set it to flange mode. And say, okay, I want one bar for a fade in and a fade out. You can multiply these settings and you can have different curves. It is bypassed. Oh, you should, of course, not bypass it. So, and there we go. That's a trick.
It's so easy to fly.
That was great, yeah.
All you gotta do, honey, is listen.
There we fast fade
So
out.
you do the time divisions and
Yeah, of course. You can sync it to tempo, although I don't know if this project uses the right tempo settings. So one machine runs at a fixed delay, and the other machine approaches from either side. So it approaches from one side, they meet in the middle, and then the volumes add up, and when it goes past that point, it's lower in volume. Yeah, and that's the regular tape flanging. So that's basically all the three modes of Satin. And
what's the processor overhead like? Is it taking a lot of use to do this, or have you managed to optimize it?
Yeah, of course we tried to optimize it a lot. To give a few measures, I'm a Windows developer. I develop all the stuff on my Windows machine, and my private machine is a dated 2.4 gigahertz dual core machine, and that consumes about 5%. And on my working machine, it's an i7 at 3 gigahertz, and there it consumes about 3%. So it's not a lot, but we just had to do it because 8 times oversampling, all that stuff, it just consumes power like nothing. Yeah.
But it sounds right.
I hope so. Yeah. We tried hard.
So how much and when?
When it. Approximately in May, so we're in the last steps, setting up things and then writing the manuals and all that stuff. And the price will be about $129 or 99 euros.